Hello, myself, Dr. Stephy Thomas from Department of Statistics, Bishop Chula Memorial College, Kotte. In this video, we are going to discuss about Wilcoxon sign rank t-test and its implementation in LibreCalc. We know that these non-parametric tests are widely used as in many of these practical situations, it may not satisfy the assumptions of these parametric tests. So Wilcoxon sign rank test is for one sample is again a non-parametric test. And this Wilcoxon non-parametric test is a Wilcoxon one sample non-parametric test is a one sample non-parametric alternative to one sample t-test. We know that in the case of this one sample t-test, we are checking whether the population has a particular mean value that is equal to mu naught. But in the case of this Wilcoxon sign rank test, we are testing median, which we will discuss further now. Now, these assumptions is particularly applicable when the assumptions of this t-test is violated. We know that a primary concern or primary assumption of this t-test is that the sample comes from a normal population. These may not hold good always, especially when we are dealing with a variable which dealing with the number of accidents or number of petals or like that. The only assumption in this non-parametric sign test, Wilcoxon sign rank test, is that the data comes from a symmetric or approximately symmetric population. And unlike in other parametric tests, commonly used parametric tests, where we use mean as a measure of center tendency, median is preferred in most of the non-parametric tests, and we are testing median in Wilcoxon sign one sample test. And the null hypothesis of this test statistic test is given by median is equal to a particular value, or we are assuming that the data comes from a population having a median value m naught. Now we will discuss the various steps in calculation of a Wilcoxon sign rank test. First, we have to state the hypothesis. We should have a clear idea about what is the value of m naught. So to illustrate or to perform these in uh, or perform it in LibreCalc, I will use a data set from the ILTS database. It is given by this one, York site. This is the data given. The scores in total scores in ILTS by the students from different countries. So I will use this data over here, and this is my data set. I have different country names over there, and scores in reading, listening, writing skill, and speak score for speaking, and total score. My hypothesis is that the for median score of total score, median of this total score equal to 7. So my m naught is trivially it is equal to 7. I have a sample of observations from different countries here. So I will find out as the first I so first as first step I am defining my null hypothesis to be as median equal to 7, or my m naught is equal to 7. Now I will calculate the differences of each observation from the hypothesized median, that is 7 here. So so for that one I will use this column G for finding out the difference. This is equal to this value, that is a value in F2. This is relative referencing is used over here, minus 7. Right. This is my difference. So this is evaluated for all the cells. So just double clicking on this autofill option will give you the values of all these values. So this is difference. Difference is calculated here. Then I will go for absolute difference. So as next step, so in the second step we have calculated the difference of observations from the uh, absolute value. Now we will exclude these exclude zero differences from this from the sample. So for that one, what I will do is I will sort the data in ascending order so that the zero values will come at the beginning, and I can exclude them for the further analysis. So for that one, I will use data sort. I am sorting by not by country name. I am sorting by differences. Then I will click OK. Now we can see that there are no cases with there are only one case with zero difference. So I will exclude that. Before this difference, I will go for a absolute difference. Absolute difference. I will go for absolute difference, which is given by ABS of the difference, which is given by this one. Now I will go for clicking these values. I will find out the absolute values of these values. Then actually I have to sort now. So data sort by absolute difference, so that my difference zero will come over here. So that I can exclude the zero values. Well, so excluding the zero values as step number 3 can be easily achieved by excluding this row in further computations. Now, as fourth step, the next step, this is what we have done over here. Now we will go for ranking the absolute differences. For ranking the absolute differences, we will use the function rank average. And this, in the case of these ties, we have to assign the average rank to each of these observations. We can see so many ties over here. So in all these ties, we will use average ranks. And one more thing which you have to keep in mind is the lowest absolute difference is should be ranked as 1, not the highest difference. So here we can see that this point 1 will be having the lowest rank, lowest rank. So in order to achieve this one, we will use the function rank average, and we will assign 1 as the third parameter in third argument in rank dot average. So this is equal to rank dot avg. We know that automatically the system will correct for positive uppercase letters. I have to find the average of this number from the vector, from these values, and the third argument is assigned as 1. Now, as I need these values for each of this observation, I will fix the range of this whole set in by using a absolute referencing, and I will click enter. So I have the first rank. You could see that all these three values, point 1 values, will have the rank 1, 2, 3, and their average rank is 2. Therefore, it has the value 2. Now we will assign ranks to each of these observations. So we could see that this is comparatively it is a large data set. Now we had completed this ranking the absolute differences. Now we will exclude as we had excluded already. We have excluded the range containing zero values in the average computation. Now, as step 5, we will compute the sum of the ranks of positive values and counting the positive differences, counting the number of cases where this positive difference is observed from the hypothesized median. Now, to find the positive ranks of positive differences, we use, or I am marking here as positive rank sum. Positive rank sum is equal to sum if. Now I am having this one as positive, so I will click this range. I want to see whether I want to see the sum of all the differences in for sum of differences which are positive. So I will select this one, all range, comma. Second argument is greater than 0, positive, sums only we need. Then I have to find out the sum of these ranks. So I will select this rank, click enter. So I will get the sum of positive ranks to be as 10.5, and how to find out the number of cases where the positive observations is observed. So number of positive cases. So for that one, I will use count if function in LibreCalc. So here also I will use this one, range, comma, condition greater than 0. And we can see that only one value has a positive value here, positive value here. So now number of rows in the range and sum of range same should be same. Now count if function is used for non-zero difference, and the test statistic is given by r plus, where r plus is the sum of positive ranks and n is the number of observations with non-zero difference, not the positive ranks. Then we have to find out the number of cases total, number of cases, non-zero cases, which is given by, so count if the difference is non-zero, that is greater than or equal to, less than or greater than or equal to 0, and close this part and enter. Now there are 32 cases in total where we observed non-zero differences, and we will compute the statistic to be a statistic is equal to r plus. So r plus is equal to r plus minus, we can see that the 4 numerator, 4 in the denominator is applicable only to n into n plus 1. So I will keep that n into n plus 1 in bracket. So n times n plus 1 divided by 4. This is the numerator, so I will keep that one to be as numerator of test statistic. Then denominator, sorry for the spelling mistake, denominator is equal to, denominator is given by square root of, so sqrt square root of n, so n star n plus 1 star 2 star n plus 1 divided by 12 whole bracket. So n into n plus 1 into 2n plus 1 by, not 12, it is 24, sorry for the name, divided by 24. So my test statistic will be equal to numerator divided by denominator. So this is test statistic. Now my alternate hypothesis, this value is not equal to 7. In that case, my, okay, we will come further. Now if my alternate hypothesis median not equal to median not, then my p-value is given by, so here comes p-value equal to 1 minus, sorry, 2 times bracket 1 minus, what was it, norm dot s dot dist value, that is absolute value of this one, abs of this value, comma, we have to use the cumulative distribution function, so 1. So we can see that this p value is very small. So when p value is less than the alpha or significance level, you have to reject the null hypothesis. So that means that here, if you assume that p value alpha is equal to 0.05, or we are testing at 5% level of significance, we will be forced to reject the null hypothesis that the median equal to 7. Hence, we can conclude that the median score for IELTS test is different from 7. This is all about this Wilcox and sign rank test. If you have any further queries, don't hesitate to drop a message in the comment box. Thank you.